All right. Advent of Code 2023, Day 8. Haunted Wasteland. Ooh, that sounds scary. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. Ooh, spooky. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled Maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some sort of network of labeled nodes. Okay? It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the Haunted Wasteland. After examining the maps for a bit, two nodes stick out, AAA and Triple Z. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach Triple Z. This format defines each node of the network individually. For example, RL, A, B, B, C, C, B, Z, D, okay. Starting with AAA, you need to look up the next element based on the next left-right instruction in your input. I assume this RL is the left-right thing. Yeah, you go right by choosing the element of A, the right element of A, and left means to choose the left element of C. By following the left-right instructions, you reach Z in 2 steps. Okay, of course you might not find Z right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. Okay. RL means RL. LLR means... Okay, so let's see if I can... This says take 6 steps. So let's see if I can duplicate that. So we're on A. We take the left, which is BBB. And we're on BBB. We take left again, which is A. So we go back to A. Then we take right. Right also sends us to B. If we go to B, now we do left. Then we're on A. We go to A. And now we do left again to get us to B. And then we take right and we get to Z. Okay. And that takes 6 steps. I think I understand it. Let's get our input for day 8. 736 insertions minus this line minus the blank line gets us 734 different things. So let's take a look. That's one disadvantage of having that. And there should be Z in there. Look at that. So obviously we have to go through JDP to get to there. All right. I think this is going to be, at least part 1 is going to be straightforward. Let's find out how hard part 1 is. And keep doing that, typing mud instead of mud. All right. So let's create the file. 2308, like that. Try to build it, and we have unsolved and unsolved. Perfect. All right, so I think parsing is going to be easy. Let lines equals AOClib, read lines, input, read text. And what do we want to store? I guess we can store a map, which maps left to right. It could be a hash set of string to, how about a vec of string? And then we're going to have a map of all of the directions, which is going to be a vec of resize, right? Then we could do store 0s and 1s in here, and then just look up 0 and 1 in there. Keen on Twitch. Thank you for the follow. Welcome. Right, that's what I'm thinking, is that we could store left as 0 and right as 1, and then we could just index into this thing, and then looping through the map would be very, very simple, right? Okay, so the first line is going to be all the L's and the R's, so we can do that. Let dirs, oh no, self dirs, let's see if we can do it in one line here, equals lines of 0 dot chars dot map, right? CH, if CH is equal to L, then it's 0, else it's 1. collect. Look at that. I think it worked. Println, and we get the ders. Look at that. I have no idea if it's right because I haven't looked at the input yet. Let's take a look. 0, 1, 0, 1, 1, 1, 0. Yeah, I think that worked. And it ends with 4 ones. It ends with 4 ones. Look at that. All right. Right. We need to get now the self ders equals. Can I do this in 1? I don't think I can do it in 1. For line in lines 1 dot dot. I can do that, right? Russell, let me do that? Or do I have to say iter? There we go. Now it says string. Okay. And I don't know why that formatted the wrong way. We're going to split it up, right? We can see take a look at what this thing looks like. We can split it with a space. Let source dests equals line dot split once on this guy, unwrap. And then let's split dests again. Let, I guess, left, right equals dests, split once. We're going to have to strip off the parens, right? So map.insert source to string, because I think these are strs, right? Yeah, so I have to toString them. And then we're going to make a vector of left of 1 dot dot. Can I do that? Or do I have to give it an ending? And then right of 0, 3 toString. Will that fit on one line? It will. Self. That failed because I forgot to close the and now I can't do map insert. Its trait bound is not satisfied. That's a new one on me. What am I doing wrong here? Hash set. Oh, the collet, thank you. I don't know why I did that. You'd think the compilation would tell me I did something wrong here because I gave it two different things here. All right, now I can't use this. I probably have to I can't just insert it as a vector like that. Tvec. There. Okay. And now if we print those out, there's going to be a million of them. But we can at least see. Let me just run it here, cargo run, and search for AAA. There it is. So AAA points to MNG and VFF, and I think that's what we saw, right? And then if I look for ZZZ, the triple Z's, there's one. So JDP, BLC, and ZZZ, and there's another one somewhere else. There isn't. Uh-oh, am I missing it? Let's dump it into a out file. ZZZ. So JDP, yeah. Oh, here it is. I don't know why I couldn't find it then. But that looks right. Okay. So I think we're good. I think we have everything we need to get going, right? This is just going to be a simple matter of starting at AAA. Let current. Let's just call it current. It's AAA. I might have to say .toString. And I can say while current is not equal to ZZZ, we're going to use the left and right. I guess we start off with whatever is in the ders, right? So let's have a pointer is equal to 0. We'll say current is equal to self map get of current unwrap. It's a little sloppy. And then it's going to be an array. So we're going to say self ders of pointer. Like that. I think that'll work. Yeah, I have to two-string it, right? Ampersand that, and then clone it out, unfortunately. There. Oh, now it's running forever because I forgot to increment pointer. Actually, you know what we can use is make this the count, and then just say count mod self-dirs len, right? And then count plus equals 1. And then the output is just the count, right? 16,271. That's the right answer. Yay. Okay. Anything we need to clean up on this? But this is kind of janky, isn't it? But it does the trick. Let's put a blank line there just to have a separation of concern. Yeah, this is pretty straightforward. Part 1. Git status. Git arm out. Git add source. Git commit -m 2023 day 8 part 1. Yeah. What's going to be another kerning problem? Do that. It took a little while, although this is debug mode. 5 milliseconds. Continue to part 2. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the map a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number of ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all the paths at the same time. Oh God, until they all simultaneously end up at nodes that end with Z. For example, and now we have numbers in here. We have two starting nodes, 11A and 22A, because they both end with A. As you follow each left-right instruction, use that instruction to simultaneously navigate away from both nodes you're currently on. All right. Let me think about this. So when I was reading this and the fact that he highlighted it, right? Significantly more steps. This is my first clue that is, we don't want to just brute force it. This might be the first puzzle that we can't just brute force our way out of. And so what I'm thinking is, instead of trying to do all paths simultaneously, we do each path individually and then figure out the least common multiple. Right? Because if we look at each one, if we look at them all simultaneously, eventually they're all going to end up on the same location, right? Because we're guaranteed to, because it's an advent of code puzzle. So we're going to have a solution. So they're all going to end up in the same spot. And the only way they're going to all end up in the same spot is if we find the multiple where they all end up. And if we can calculate each path individually and then get the least common multiple of all of those paths, I think that'll give us the answer. No spoilers. All right. So how do we do this? We're going to come up with a list of things to work on. So it's I don't know. This is our input queue. This will be self map value keys. We want to look at all the keys, and we're going to filter any key that ends with A, and we're going to collect those. Oops. So that's a vector of strings. And that's going to be the list of things we need to work on. So we're going to say for entry in queue, And now we basically just implement this, except, so maybe I should refactor this code here. Yeah, let's refactor this code. And I can give it a starting, oh. Yeah, I don't know. Okay, I guess we don't need to refactor it. The reason I was hesitating is because this is definitely ending on a ZZZZ here, but here it says we're going to end on any node that ends in Z. So we just have to look for a Z. We don't know which one it's going to end up being. Right, so we have to look just to see. Okay, so we'll basically just copy let mut current equals entry clone. Right, because we're gonna walk our way through it, and then we're gonna say that mut count is equal to 0, while current, not current, ends with Z. Right? We'll say current equals. I guess we can extract this line. Let's do that at least. Pub fun get, and we can pass in, right? This will be a reference to a string, and then our count, which is usize, and it'll return a string. Right? Let's call it that. Do that. Something's missing here. Oh, I need self. Still not liking it. Oh, maybe because I haven't finished this here. Okay, so let's do that here. Self get current and count. Let's pull this away. And, what we can do is just for part 2, let's print in the queue to see what kind of numbers we're dealing with here. Okay, so it's still 271. I think that was the number. Yeah, that's the number. Okay, so it was only 6. Okay, that's not bad. All right, but now we've extracted the get, so this should be easy. While not current ends with Z, current equals self get current and count plus equals 1, and then we can say println entry goes to current in count steps. Right, I think that'll do it. Yeah, see, so we got these 6 numbers here, and this is going to repeat. Oh, is there like an MFZ? Yeah. I mean, this has to be. We have to be on the right track at least. I'm gonna see if this is good enough. Because right, MFZ is gonna have to keep looping. Right, but I don't know if it'll still be this number of steps. But if we can figure out the least common multiple, and it's going to probably be big, because all these look like they all end in 1, 7, or 9, so they're probably all primes. So I bet you if we just have to multiply them together. Although it would be nice to add a least common multiple calculator. Yeah, okay. As a first approximation, let's find out if they're all primes. Multiplicative overflow. And I'm using 64-bit integers, so I'm guessing that they're not primes then. Will this be cheating if I look them up? Is prime? No. Okay, so they're not primes. All right. So we do have to calculate the least common multiple. I know off the top of my head, LCM of x and y is equal to x times y divided by the greatest common divisor of x and y. That's the thing I got stuck in my brain. So we just have to figure out how to do GCD. And I think it's just you reduce it based on the mod of x and y. Something like GCD of x and y. I should put these in parentheses. Of x and y is equal to, you have to reduce it down, GCD. If y is 0, then it's x. Else, it's the GCD of y and x mod y. I think. I gotta look it up. And then what I can do is I can add it to my Euclidean algorithm. Holy crow. Okay, never go to that website. This is the Euclidean algorithm. Using the quotient and remainder. Yeah. Okay, I think I got it right then. This is the Euclidean algorithm for GCD. Nobody says I'm using this, least common multiple. Copy link address. Paste. Oh, here's the calculation. Yeah. This is it. Okay, I think that's what I have. Very good. Okay, that's what we're going to do. Yeah, that's what we're going to do. So let's just write this. Oh, we have multiple. We have 6 numbers to reduce. That's fine. Let me write the ones for GCD of just x and is u size and y as u size and returns a u size, and it's just this code that I wrote, right? Except I don't want that there, right? And then we can write the LCM for 2 numbers. X as u size, y as u size, and read the u size, and we just return x times y divided by GCD of x and y without that. Okay, I think we're getting close. And now we just need ones that work on lists. Fn GCD of u size, and that returns u size. No function overloading in Rust, is there? Unless we did traits, and I'm not going to do that right now. So we just need to work our way through all of them. What's a nice functional way to do this? Obviously with a fold, but we need a starting position for our fold, which I don't know how to do off the top of my head. I need to give this a name. The way I would do it in C, right? We'd do first equals let iter equals list iter, iter next unwrap, let second equals iter next unwrap, let answer equals GCD of first and second, and then while let sum next is equal to iter next. Oh, can I just do that? No, I have to put iter next on it. Okay, I have to put next. Yeah. Oh, that's a reference. These references as well? They are. Okay, let's deref those. Can I do that? And then answer equals GCD of answer and next. And we just return answer. Rom says reduce is a fold without an initial value. Okay, I haven't used reduce before, so that would be something new to learn. Remove this mut. I don't need this to be mutable. Cannot assign twice to mutable. So I put a mutable there, and I forgot to put a mutable here. Okay. So I should be able to print out. Let me get the answer, and then I'll learn how to use reduce, because that would be a good tool to have in my tool chest. So instead of multiplying the answers, we're going to make a vector of answers. All right, I'll just say vec new, and then say ans push count. And then I can get the GCD of all of those guys, right? GCD of this, which apparently is 307. That's a good start. We've successfully calculated, well, I assume we successfully calculated the GCD. And now we need to write LCM of. Let's put these together here. And it's just the same exact code. Right? And then I'll figure out how to do the reduce. LCM. 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 Right? And we don't need these guys anymore. Okay, so now so I actually didn't need this GCD of, but I wrote it anyway. I'm going to throw it in my, that's an enormous number. At least it fits in 64 bits. Yay, that's the right answer. Okay, so my initial worry, I was worried that, the cycle wouldn't repeat the same length, but I guess it does. Because once you hit MFZ, you got to, right? Because that's what it was saying, is that they all have to end up in the same paths at the same time until they all end in